We'll proceed in pseudo calculus problems. Pseudo calculus problems. Pseudo calculus problem. The topic in which we have started a new discussion. Pseudo calculus problems, and there we are trying to find area of a circle that is described in polar coordinates. Area of a circle can be generally it is described in Cartesian coordinates. If I have a circle that is x square plus y square equal to a square, if I have a circle that is x square plus y square equal to a square, rather than I have one equation x square plus y square equal to a square, then equal to plus minus square root of a square minus x square, y equal to plus minus square root of a square minus x square. Okay, if this is the case, then someone can start drawing it. Y equal to plus minus square root of a square minus x square. Keep varying the value of x and see what is plus and minus y. Okay, when x is in between minus a to a, including minus a to a, when x is including minus a to a, or rather if I say minus a to a is the x. If x goes beyond a, then a square minus x square, square root will become an imaginary number. We'll talk about imaginary number. There is nothing called imaginary. Everything is practical only. Anyway, but whatever. We are not right now looking for the square root of negative number. So in that fashion, x would go minus a to a, including minus a to a. Now, if that is the case, then we have this y equal to plus minus square root of a square minus x square. This is a equation of this will draw a circle. Okay, this will typically it will draw a circle. If this is okay, if this is x-axis, this is minus a, this is plus a, this is origin. X goes from minus a to plus a. Accordingly, y, that is the height, that is changing. Y equal to plus minus square root of a square minus x square. Plus and minus, plus and minus, plus and minus. It will make a circle. So Cartesian coordinate system, there we have a equation of a circle, that is y equal to plus minus square root of a square minus x square, or y square equal to a square minus x square, or y square plus x square equal to a square. This is algebra. Y square plus x square equal to a square. This is algebra. This is not calculus. Calculus is y equal to plus minus square root of a square minus x square. Y as a function of x. This is calculus, algebra. Anyway, now concept is coming that I can represent this Cartesian coordinate system into a polar coordinate system. Polar coordinate system, every coordinate system, the coordinates are orthogonal to each other. If I say Cartesian coordinate system, x-axis and y-axis, they are at 90 degree. If I take a two-dimensional shape, then can I have another two entity? They are at 90 degree to each other. If this is a circle and this is center of the circle and this is radius, then everywhere radius moves like this, and everywhere radius is making 90 degree to the arc. 90 degree exactly means arc and this line. Rather than saying radius, I would say I'm drawing a line from the center of the circle to the perimeter. Okay, if I draw anyway, keeping the one end at the center, this line will be perpendicular to the perimeter at that moment. Means perimeter and line, since they are perpendicular to each other, this is giving a hint towards another coordinate system. Because coordinate system means if I have 2D shape, if I have any 2D shape, and in 2D shape can be described by two orthogonal lines, these definitions are not there in any of the book. If any 2D shape is described by any two orthogonal line, then these two orthogonal line make a coordinate system. Any 2D shape can be described by x-axis and y-axis. Like we said, even though it is not a rectangle, what we can write y equal to plus minus square root of a square minus x square. Means this line can be represented in x and y, possible. There can be another from center. If I draw a line toward the parameter, then it is again this line and this line, curved line, are perpendicular to each other. This hints about another coordinate system. This is called polar coordinate system. If this is radius, if I call this line as radius, means radius starts from origin and it starts growing, and it hits the parameter. That line is called radius. Okay, if I say radius, it is hitting the parameter at that moment. At that moment, parameter line is constant. I'm talking about a particular line only. In the touching that line from center, radius starts growing. Okay, if I take this point on the parameter, constant point, from the center, if I make this line grow, and it will touch this, keeping this point as constant, I grew the radius. Or I can keep radius as constant. Radius will not grow. And then start moving along the perimeter. Okay, then okay, this is, if I keep this point constant and make it grow, this line is called radius. If I keep radius constant and start moving like this line is called arc. Okay, and in this arc, radius, what is the length of this arc? If I move from here to here, what is length of this arc? Okay, length of radius I understood. Keeping the arc point constant, length of radius is from center to this point. If I grow like this, it becomes radius line. If I keep radius constant and start moving, what is length of this arc? If here, and here, there is a theta angle, it moves. Radius start moving in angle. It makes an angle. If this is theta, it moved. Then this arc is r theta. R theta means any point, if I talk here, this point is r comma r theta. R comma r theta, where r is the radius and r theta is the arc. Okay, but in r theta, if I see, when I kept radius is constant, then theta is the actual variable. So we call it another coordinate system is r theta coordinate system or polar coordinate system. Now, what is relationship between Cartesian and polar coordinate system? Then if I have a radius and this makes angle x theta with the x-axis, this is x-axis, this is y-axis. If there is radius is up till here only, this is not the radius, up till here only. If radius makes angle theta with the x-axis, then x-axis at any moment, what is x-axis? If I draw a straight line from here, it will cut the x-axis at this point. This is x. I'm not talking about, this is full radius. From here, from center to here, it is full radius. From here, if I draw a vertical line, this is x. If I go up, then x will become smaller. How much is the x? How much is the x? This x is r cos theta. How much is the y? It makes interception on y-axis. That is r sine theta. Here, if I do like this, then it will make interception on y-axis this much only. If I go like, the interception on y-axis will grow. If I go completely, when theta is 90 degree, full interception on y-axis is made. Y equal to r sine theta. Sine 90 degree is 1. So r sine theta, x equal to r cos theta. This is the relationship between the Cartesian coordinate and polar coordinate system as far as this circle is represented through. The circle is represented through two orthogonal coordinate system. One is through x and y, where y equal to plus minus a square root of a square minus x square. One is through polar coordinate system, where if I take about the circle, then r is constant. Everywhere r is constant and theta is from 0 to 2 pi. If the radius of the circle is a, then r is a. Everywhere r is a, where theta moves and it makes 0 to 2 pi. Okay, so In xy coordinate system, y is dependent upon x. Y equal to plus minus the square root of a square minus x square. In polar coordinate system, r and theta are not related to each other. R is independent, that is constant a. Theta is 0 to 2 pi. If I take r theta plane, if I take r theta plane, okay, if I take r theta plane, if I take r theta plane, then theta is from 0 to 2 pi, where r is kept constant a. It forms a rectangle. If I take theta r plane and there is a xy plane, in xy plane if there is a circle, then in theta r plane there is a rectangle. Mapping of a circle in theta r plane is a rectangle. Okay, what is the area of this rectangle is 2 pi into a. 2 pi a, whatever someone consider, he can consider. I am not stopping anyone. But this is how it is. In theta r plane, this is theta going from 0 to 2 pi, and a is constant here, okay, always. Whereas mapping of this theta r plane in xy plane is a circle where y equal to plus minus square root of a square minus x square. If I talk about the interdependency of each other, then x and y as a function of theta and r, I can take r as a function of x and y, theta as function of x and y, or x as a function of r theta and y as a function of r theta. Anything I can take. X equal to r cos theta, y equal to r sin theta. Okay, I believe it is all right. If that is the case, if in that case, we have now, this is how the relationship between these two are. Now the concept is that I have another scenario. Here, this radius is not independent of this angle theta, r equal to cos theta. This is a typical case, r equal to cos theta. If radius and theta plane, they are not making rectangle, rather than they are making a cosine, rather they are making a cosine. So cosine will be like this, okay, it will be like this. This is cosine. Cosine will be like this. Okay, means here it will start with 1 and then 0 and then minus 1, 0, 1 like this. Miss R, miss it will be like this. Oh, it will go negative also. It is tedious though. It will be like this. This is the this is the r theta plane. Now r equal to cos theta. If r equal to cos theta, then what shape it will make in xy plane? That is the first question. Second question is what is the area of the shape? Now we have x equal to r cos theta. That relationship is carried. Y equal to r sin theta. Now r is cos theta. X equal to cos square theta. Cos theta, cos theta, cos square theta. Y equal to r sin theta. Cos theta, sin theta. X square plus y square equal to cos to the power 4 theta plus cos square theta sin square theta. It will become cos square theta only. Cos square theta plus sin square theta will become 1. Means x square plus y square equal to cos square theta. That is x. That will become x square minus x plus y square equal to 0. That will become x minus 1 by 2 whole square plus y square minus 1 by 4 equal to 0. That will become x minus 1 by 2 whole square plus y by y whole square equal to 1 by 2 whole square. This is the equation of a shifted circle. So these things we have talked in the previous video. Okay, this is the equation of a shifted circle. What is shifted circle is, if this is a circle and it is centered at the origin, okay, so if this is a circle and it is centered, consider this is x-axis and this is y-axis. If this is the circle centered at the origin, then this equation is x square plus y square equal to a square. If I am saying x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square, this is the shifted. Now circle is shifting toward x-axis. And now It is centered at a point called 1 by 2 comma 0 with radius 1 by 2. Left side of the circle is hitting y-axis, and then above the x-axis half of the circle is there. One means the circle is shifted only along the x-axis. Now the equation, since it shifted half, so x square plus y square equal to 1 by 2 whole square is the equation of circle that is centered at the origin and radius half. If I shifting it half, then x minus 1 by 2, x minus half will come. If I had shifted it to a, if center is origin, now center is at a, then this will become x minus a whole square plus y square equal to 1 by 2 whole square. Centered at a comma 0, radius 1 by 2, but it shifted 1 by 2. So it is x minus 1 by 2 whole square plus y square equal to 1 by 2 square. Means if in r theta plane, if I have a equation is r equal to cos theta, then in xy plane I have a circle with radius 1 by 2 and shift center as 1 by 2 comma 0, means x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. What is the area of the circle? Then pi r square is the area of circle. Pi into r is 1 by 2, 1 by 4. Pi by 4 is the area of circle. It doesn't matter where it is. If it is centered at the origin, all right, wherever it is, the area of the circle is pi r square only. Pi into 1 by 2 whole, pi by 4. Anyway, can you prove it? What do you want to prove? R equal to cos theta. I have a polar coordinate equation r equal to cos theta. Can you, whatever shape it is making, can you draw the shape r equal to cos theta? Okay, let's try this shape. So I just said r equal to cos theta in r theta plane. In xy plane, let's draw the r and theta. In r and theta plane, I drew it as a cos wave. In xy plane also I can draw r theta. If I draw r is a and theta is 0 to pi, then r is a and theta is 0 to pi, it will make a circle. But what about r equal to cos theta? If consider this is origin in xy plane and this is r, this is radius. Consider this is radius, r equal to cos theta. When theta is 0, angle is 0, this is x-axis. When angle is 0, when theta is 0, then r equal to 1. Okay, now r will start increase. Now radius will start changing when theta is something. If theta is 60 degree, theta is 60 degree, then r equal to half. Means radius came to this. Radius started from big 1 and at 60 degree it became half. It is like this. Can someone see this? Okay, when theta is 90 degree, then radius is 0. Means radius started from here. It started becoming less, and at origin, means when angle is 90 degree, angle is growing, right? When angle is 90 degree, this radius became 0. There is no radius at all. Okay, after that, when radius, okay, leave it. We will draw it. Anyway, let's find the area of the shape, that is r equal to cos theta. Now, if I take in Cartesian coordinate system and if I'm trying to find the area of something, then this is area. And in this area, I take any point P here. Any point P here. If point P, consider this is origin. This is origin. This is x-axis. This is y-axis. This is z-axis. Okay. Now I am taking a area, circular area somewhere. Now on this is a surface, 3D surface. Okay. Now there is any point P here. Any point P here. If there is any point P here, then from the origin, the position vector of this P will be, what is the point P? That is xi plus yj plus zk. That is the point P. X means point P is x comma y comma z. From center, if I draw a line, then it will be called position vector of a area point. Point P belongs to area. It is not a line point. means position vector xi plus yj plus zk connecting origin and x comma y comma z. This is position vector, capital P on top of it arrow mark. If I connect a line from origin to any point P, then this is called position vector. Any point, what P, any point. From origin, if I draw a line, then this is called position vector. Now, position vector belongs to a point P x comma y comma z on area. Okay, in that sense, this is position vector for a point that represent an area point. D of P, derivative of P will be another vector that will be along the surface. This is inherent nature of calculus. How it is? Please watch our previous videos where we have proved the derivative of a position vector is another vector that is along the surface, or if the position vector represents a line, consider there is a curved line. Instead of circular line, there is a curved line. Instead of circular line, there is a curved line. And this is the point P here, x comma y comma z. And this is origin. If I draw a line that is position vector, then this is position vector. If I calculate derivative of this position vector, another vector will come, and that will, if this is point P, that will be tangential along the line. That will be another vector. This is the inherent nature of calculus. Derivative of position vector is another vector that will be along the line along the surface. If this point P, I'm not talking about this line now. This is a surface. Consider this is filled one. There is no hollow here. This is filled one. And this is a surface. This is origin. I take any point on this surface here. Any point on this surface here, P. Then P is x comma y comma z. From here, if I draw a line, this is called position vector of P. Position vector P vector, I call it P vector. P vector represents a position vector of a point that represents an area. D of P, derivative of P will be another vector. Derivative of P will be another vector that will be along the surface. That will be along the surface. If that is the case, D of P, derivative of P, means D of xi plus yj plus zk, D of xi plus yj plus zk will give the kind of a surface vector, surface area vector. Means D of P, if I calculate magnitude of the surface area vector, I'll get the area. Idea is to calculate the area of this filled circle. There is no hollow here. Filled circle. Derivative of position vector. Position vector is xi plus yj plus zk. Derivative will become dxi plus dyj plus dzk. Okay. In that sense, D of P will give the area. This is pseudo term. D of P, small d, capital P, on top of it arrow mark, D of position vector. D of P is same as D of P by D theta r into D theta r as per the simple mathematics. Y equal to Y into X by X. Simple. So D of P is D of P by D r theta into D r theta. Means D of P by D r theta. Since P is a position vector of an area, D of P means change in the position area vector by D of theta r. Means if I have a position vector is in xy plane, okay, position vector if I see, then that is, I'm sorry, so I'll rephrase this. Consider this is okay, consider this is xy plane, this is x-axis, this is y-axis, and this is z-axis. This is xy plane. This is theta r plane. On xy plane, I have a 3D shape that is a filled circle. And in this 3D shape, I have any point P here. Now I am saying dP by d theta r. dP by d theta r. Okay, means if this is r theta plane, this is xy plane. On top of it, xy plane, I have a 3D shape where point P is there. Anyway, dP by, now this is theta r plane, this is xy plane. dP by d theta r. dP by d theta r means if I make 1 unit of area change in theta r plane, theta r, 2-dimensional, means area. If dP by d theta I say single dimension, only theta. dP by d theta r If I make 1 unit of area change in theta r plane, if I make 1 unit of area change in theta r plane, 1 unit of area change in theta r plane, then how many unit of area change I see in the P? P is a point on a surface. Okay, since P is x comma y comma z, where x comma y, if I draw a vertical line on xy plane, it will represent a point called x comma y, and z is the height. Means P is highly associated to point x comma y on xy plane, and a height is nothing but function over x comma y. I believe it is all right. So now x, so P is connected to xy plane, and xy plane is connected to theta r plane. In theta r plane, if I make 1 unit change, there is any point theta comma r, accordingly we have point x comma y in xy plane, and accordingly we have a point called x comma y comma function over x comma y, that is z, that is the height. At any theta comma r, if I make 1 unit of area change, then how much unit of area change I see around the P? dP by d theta r. Please watch our previous video. That results in dP by d theta cross dP by dr. Okay, where we made a, at any point, if I take here, that correspond to point P. Point P, if I make a line, it will correspond to point P on xy plane. Then from xy plane, if I take a mapping, that is x equal to r cos theta and y equal to r sin theta, then here the point P will come here from 3D to xy plane to here. In this theta r plane, if I make delta theta change, then another point will come theta plus delta theta comma r. In theta r plane at point theta comma r, if I make delta r change, then there will be another point called theta comma r plus delta r. This axis is theta axis, this is r axis. Now I made a change in the area at point theta comma r, delta theta delta r. In that fashion, here it is mapping to a circle, it is mapping to a shape. How much area change I see here? Accordingly, in the 3D shape at point P, how much area change I am seeing? That will result into dP by d theta cross dP by dr. Okay, and numerator we had d theta r, that will become d theta dr, delta theta delta r. Then it becomes d theta dr. This is called area vector. This is called area vector. dP by d theta cross dP by dr into d theta dr. This is top class area vector. Where the caveat is where P position vector is in x, y, z, not in theta r, in theta r, in theta r, in x, y, and z. This is the position vector in x, y, and z. Okay, now dP by d theta. What is x, what is y, what is z? Unfortunately, we are not interested in z because our surface, our field circle is kept on xy plane only. There is no z here, so z concept is gone. Okay, now for the generic term we had included z. Anyway, now if that is the case, or I can take, or if somebody is interested in z, then I can take a circle on the xy plane and I can take circle on the z plane also. I mean it will form a cylinder where z is constant 1. Okay, because we are trying to find a circular region that will be parallel to xy plane and area of this region. Okay, then if this is xy plane and there is a circle, I'll take another circle exactly homogeneous to this and on the z axis where z is 1. Okay, then it is same thing anyway. Or just remove the concept of z. Now dP by d theta cross dP by dr. Now P is xi plus yj. Then it will become dx by d theta I plus dy by d theta j. Okay, cross dx by dri plus dy by drj, d theta dr. X equal to r cos theta, y equal to r sin theta. In that sense, dp by d theta will become r minus sin theta I plus r cos theta j. Okay, cross product dp by dr cos theta I plus sin theta j. If someone does this cross product of these two, it will, we had done in past video, it will become minus r k vector, simply minus r k vector, minus r k vector d theta dr. This is the area vector of a circle in theta and r only, and with k vector means Cartesian coordinate is hinting there. Okay, means if it is kept on theta or xy plane, this surface area vector will be towards k axis minus r k unit vector d theta dr. If I want area, then I have to calculate magnitude of this. It will become r d theta dr. Okay, integration of this r and theta. R is from 0 to cos theta. This is the limit we are taking. R is not 0 to a because we have function of r and theta. R is dependent upon theta. R is from 0 to cos pi, cos theta, and theta is 0 to 2 pi. Now it will become, because it is a circle, right? We expect that r equal to cos theta is a circle. Now in that, it is a circle, right? X minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. We saw it. It is a circle. It means full 2 pi. R is 0 to cos theta and theta is 0 to 2 pi. R dr d theta, r square by 2. R is 0 to cos theta. It will become cos square theta by 2. 1 by 2 I can keep outside. Cos square theta d theta. Integration will be cos square theta d will be theta by 2 plus, I believe so, sine 2 theta by 4. Now 0 to 2 pi. If I keep pi, then it becomes pi by 2. Theta by 2 will become 2 pi, means 2 will go away. Pi, just pi. Pi minus 0, sine of any pi, 2 pi all are 0. Minus 0, all 0, means it becomes pi. And outside 2. Pi by 2 is the area of the circle. But we calculated in the previous case, pi by 4 was the area of the circle, not pi by 2 is the area of the circle. Where we have done the mistake. So let's go back again. Okay, we are trying to draw the circle with the r equal to cos theta. If we are trying to draw the circle with r equal to cos theta, when theta is 0, then this is origin and this is radius will vary like this. If r is constant a irrespective of theta, it will make an arc like this full and it will make a circle centered at the origin. But r equal to cos theta. When r equal to cos theta, means theta is 0, the radius is 1. When theta is pi by 2, radius is 1 by a square root. Radius will start decreasing. Here radius is this is origin. Here radius is 1, the radius will start decreasing. When we are increasing the angle, when angle is pi by 2, radius becomes completely 0. When it grows beyond pi by 2, means now radius started from here and it became pi by 2, where the length of radius becomes 0, unfortunately. Now radius is going beyond the pi by 2. If it goes beyond the pi by 2, it will go in negative. Radius will become negative. Means, and when it becomes pi, the radius will become minus 1. If radius is negative, then negative radius can be drawn exactly at 180 degree. I believe it is all right. If here radius is, consider this radius is negative at angle 30, then this radius can be drawn exactly 180 degree from here. That will come exactly here. This is one, means a straight line. If this is origin, and consider this is the radius is minus 1. Instead of 1, at angle 0, this is angle 0, angle is growing. At angle, radius is minus 1. Means radius is exactly 180 degree. This is a radius. Minus, radius in minus means opposite direction. Okay, so radius started from 1 and at 90 degree radius becomes 0. It became like this. And then when radius is growing like this, angle is growing like this, radius starts becoming negative. Means radius will become like this. And then negative, this is positive now and it will go like this. When it is pi, then radius will become minus 1, means 1 on this side. Means it will form a circle. Anyway, we saw that it forms a circle. The circle will form like this. It will go and at 90 degree it will come here. Beyond 90 degree it will start like this and it will go like this. It forms a circle. We saw it really forms a circle centered at half. Centered at the half, it forms a circle. If it is 1 and this is 0, then this is half. This is a circle, it forms a circle, but angle of the circle is only pi, not 2 pi. It starts from 0, radius starts from 0 angle and it goes 90 degree. Beyond a 90 degree it becomes negative and radius shifted exactly opposite. And then it went till pi. This angle is 0 to pi only, not 2 pi. So we will rechange our limit. Radius is 0 to radius is 0 to cos theta and theta is 0 to pi. In that sense, it becomes cos square by 2 r dr r square by 2 cos square theta by 2. 1 by 2 I can keep outside. Now it becomes cos square theta d theta. Theta by 2 my plus sine 2 theta by 4. 0 to pi. Then it becomes pi by 2. Other everything will go away. Pi by 2 into 1 by 2 is pi by 4. This is exactly what we got pi by 4. The person can try anything more here. Okay, we will see more on it. We just tried that xy plane and theta are plane. Can we compute everything in theta are plane? Kick out xy plane. I don't want position vector in xi plus yj plus zk. Everything in polar coordinate system only. Can we again draw the area of this circle, that is r equal to cos theta? Please do not mind supporting us. Plus 91 is the India country code. 9483160610 is the telephone number. Plus 91 is the India country code. 9483160610 is the telephone number.